is not possible, a feeder pillar box of suitable size may be used to protect the earthing pit. Such unbarricaded earthing pit shall be at least 1.2 meter away from the road. So these are the rules for installing earthing pits. Now, we shall look at how system earth and equipment earth are interconnected. And obviously, we would need Mayank's expertise to understand this better. Let's welcome him once again. Hi Mayank, please help us understand the connection between system earth and equipment earth.
I will be glad to explain. We will understand this through an animation. Let us say this is an equipment pit wherein the non-current carrying parts are grounded. You can also see that there is a neutral bus bar and further there is a neutral pit. Here we can see that the live part is grounded. Now suppose there is some maintenance work or testing to be carried out near neutral earth pit, suppose pit B. So since it is connected with the live part, the testing or maintenance cannot be done online. This connection needs to be isolated first. However, isolating it will destabilize the power system.
Oh, then?
Therefore, before putting off switch B to disconnect the power, we will put on switch A first and then put off switch B. Doing this will cause the neutral of the transformer to connect with the mass of earth through the equipment bus bar. This will allow the power to be disconnected to pit B without disturbing power to the installation and work can be carried out. This is all about the connection between system earth and equipment earth.
That was indeed interesting. Thank you.
Pleasure is all mine.
Let us further learn about maintenance of earth pits. In the process of maintenance of earth pits, the first step is commissioning. Let us look at what are the steps that need to be followed in commissioning. Before commissioning earthing pits, it shall be filled with a proportionate mixture of 50 kg common salt, 300 kg of water and 1500 kg of soil. Ensure overall cleaning of earthing pit and earth system resistance should be measured by earth testing measure and the combined value should be less than 1 ohm. Let us move on to next step, that is inspection. In the inspection phase, all earthing systems shall be visually inspected before testing. This includes checking whether there is distinct earth pit for equipment and neutral earthing, checking whether two distinct leads have been terminated at the respective pits, ensuring overall cleaning, ensuring condition of earthing resistor and link thereof, checking the condition of earthing pit and masonry work, checking electrodes connection and their rigidity and the condition of earth electrodes above ground level. Once voltage is checked across earth electrode and earthing lead is found to be below 5 volt, testing is done. The next step is to test the resistance of earthing pit. It is advisable to test earth resistance during dry day, dry season in order to get conservative results. Further, records shall be maintained for the initial earthing resistance and subsequent earthing resistance. In this context, it is important to have a look at this table. The table here conveys how the resistance of earthing pit varies depending upon the seasonal condition. For example, if you take a look, the value of each month differ. While there is a lower value in July, January has a higher value. Therefore, you can see that the resistance values vary with the season. Also, if you look at the last row, the values have been consistently high in the month of January across all the 3 stations. Therefore, maintenance of each earth pit should be done when the resistance values are high. Further, this maintenance should be done during the dry seasons only, that is between January to March. So now we know that earth resistance varies from season to season. Well, let us look at a few more specifications in this context. Resistance should be measured during dry day and dry season. For low and medium voltage, it should be done in not less than once in 2 years. For high and extra high voltage, it should be done in not less than once a year. Identify the earthing station group to be tested. If resistance value is found high, that is over 1 ohm, then only individual station shall be tested. Test power in case of system earth. Caution tag shall be fixed at isolating point. Voltage shall be checked and this shall be within 5 volts. Only insulated lead should be used. The lead should be as short as possible. Current electrode shall be placed at least 30 meters away from earthing station and potential electrode midway between them. Auxiliary electrode, usually consisting of 12.5 mm diameter, mild steel rod shall be driven into the ground up to depth of 1 meter. The value of resistance to earth for each group of connected earthing pits shall not be more than 1 ohm for all range of voltages. Record of such test should be maintained for future reference. Old value, which is written on the nameplate, should be replaced by new one. Let us now look at the process of how earth electrode resistance is measured. As you can see in this diagram, there is a megger. There is an electrical circuit inside the megger and outside it as well. The labels C1, P1, P2, C2 are all terminals of the megger. Whenever the handle of the megger moves, it generates some amount of DC voltage. This voltage, say 50 volts, depending upon the rating of the megger, is applied across the C and E terminals. This causes flow of current through the soil into the current coil of earth testing megger. Now the voltage is measured across E and P terminals by potential coil. The torque developed is proportional to V by I, which in turn gives the value of earth or soil resistance, and the current is passing through the soil. Depending on the soil resistivity, the megger senses the amount of current passing through the devices in terms of how much voltage is applied and how much current is going through the soil. So, to measure the earth resistance, the voltage generated needs to be divided by the amount of current passing through. This division will give an idea about earth resistance. Therefore, the megger is crucial in finding out the earth electrode resistance measurement. It is also referred to as earth testing megger. This is all about the earth resistance measurement process.